All right, Math 2, here we go. We've got Lesson 10-7, Graphing with Intercept Form. Our question today is, how do you find the vertex using Intercept Form? All right, so we've got three forms that we've been working with. We've got Vertex Form. This is the best form for graphing because it gives the vertex. We've got Standard Form. Standard Form gave us our y-intercept, and it gave us our a value, where we could tell if it faced up or faced down. How wide it was. Then we got intercept form, which we says gives the X-intercepts. So each form tells us something a little bit different about our quadratic function. And we can jump from one form to another. Let's say that we get started with vertex form, which gives us our vertex. We can multiply x plus 2 times x plus 2. So if I do x plus 2 times x plus 2, x plus 2, x plus 2. So I'd get x squared, I'd get 2x, 2x, and 4. So I got like terms in a little peanut right there. So this is y equals x squared plus 4x plus 4, and then minus 9. Okay, then I would combine these two like terms right here, and I get y equals x squared plus 4x minus 5. And now we are in standard form. So now I can take this, and now it is in standard form. So standard form for this one would be y equals x squared plus 4x minus 5. So vertex form, written in standard form, would be this. If I wanted to take standard form and change it into intercept form, I would factor this part over here. So I've got a negative 5 over here. So this is trinomial factoring. So there's only two factors of negative 5, 1 and negative 5. Or we could do negative 1 and positive 5. And these two would give us the 4x there. So I could split this up into y equals x minus 1 times x plus 5. And now we've taken our standard form and switched it into intercept form. So intercept form for that one would be y equals x minus 1 x plus 5. So these three functions are the same exact function. If you were to graph them, they would give you the same graph. So starting at vertex form, I can change it to standard form just by multiplying this out and then combining like terms. When something's in standard form, you can factor it, and then it becomes intercept form. Okay, so when we're graphing using intercept form, we have to recognize what intercept form gives us. Intercept form gives us the X-intercepts. Let's do pink, I like pink. So it gives So let's just say that I've got a graph here. And let's say, I don't know, let's say that the intercepts are at 1 and 3. Okay, so in a situation like this might mean that we had a function where it was x minus 1, x minus 3. So our intercepts, remember we set these equal to 0. So this one would be positive 1, this would be positive 3. So these would be our two intercepts. Now, if I wanted to graph the rest of the function, I'd need some other information. if we've got our axis of symmetry and it runs down the middle so that it splits it into mirror images, over here we've got these 2 points and there should be a mirror image across a line right between them. So this means that my axis of symmetry has to be right directly between my 2 intercepts. In this case, x equals 2 would be my axis of symmetry. So the axis of symmetry is always midway between the x-intercepts. So I have my 2 x-intercepts here. My axis of symmetry has to be right in between them. So in this case, we would have figured out, oh, my x-intercept or my axis of symmetry is 2 because my intercepts were at 1 and 3. So my axis of symmetry has to be at 2. Now, the nice thing about knowing your axis of symmetry is your vertex is always somewhere on this axis of symmetry. So the vertex is always on the axis of symmetry. So if you want to find your vertex, you're going to plug in the value of the axis of symmetry into x to find y. We're going to do that in a second down here. And lastly, if we want to find the y-intercept, remember all we have to do is plug in 0 for x. All right, so here we go. We're going to use this information here to graph this one. Right now, this one is in standard form. We're going to put it into intercept form so that we can find the x-intercepts. Okay, so we're going to go ahead and factor this. So I'm looking for things that multiply to give me 5, but add to give me -6. So the only way that this is going to work is if both of my factors are negative. Because -1 times -5 is +5, and then -1 minus 5 is -6. Okay, so I factor it. I know that this is going to split up into x minus 1, x minus 5. Okay, so since this is in factored form, this tells us what our 2 x-intercepts are. We always use the opposite of these 2 numbers. Because remember from last time what we did here is we did x plus 1 equals 0 and x minus 5, x minus 1. X minus 1 equals 0 and x minus 5 equals 0. Because remember when we were solving in the last section, what we did is to find the x-intercepts and we called them the zeros of the function. What else did we call them? We called them the roots of the function, the solutions to whatever it is. It's always when y is equal to 0. So if I put a 0 here, then I would set these two equal to 0 using the principle of zero products. So my 2 x-intercepts, if I add 1 to this side, I get x equals 1. If I add 5 to this side, I get x equals 5. So my x-intercepts are at 1 and 5. So let's go ahead and graph those. Here's 1, 2, 3, 4, 5, and here's 5. All right, so I got a good start to this. So now what I'm going to do is I'm going to go to this next part and I'm going to find my axis of symmetry. The axis of symmetry is always midway between the x-intercepts. So my axis of symmetry is always going to be halfway in between there. Well, halfway in between is going to be this line right here. Okay, that's going to be the halfway mark. So what is the equation of that? That is x equals 1, 2, 3, x equals 3. Okay, so why is that important? Well, the axis of symmetry, in order to find the vertex, we plug in the value of the axis of symmetry into x to find y, and that's where our vertex is, because our vertex is somewhere on this line. And anywhere on this line, x is equal to 3. So to find the vertex, I'm going to plug in 3 over here into these two right here. So I'm going to do y is equal to 3 minus 1 and 3 minus 5. So this, of course, is going to give me 2 and negative 2. 2 times negative 2 is negative 4. Oops, my bad. So my vertex, I plugged in 3. And my y value was negative 4. So 3, negative 4 is going to be my vertex. So 3, 1, 2, 3, and negative 1, 2, 3, 4. Okay, there's my vertex. Now we can find another point using the y-intercept. The y-intercept is when y is 0. So if I plug in a 0 to these two, x is 0, gosh, what am I doing? X is 0. If I get 0 here and 0 here, this is the y-intercept. So in standard form, that's the y-intercept. So if I go over here, 1, 2, 3, 4, 5, there's my y-intercept. And remember, the axis of symmetry is a mirror image. So this is 1, 2, 3 away. So if I go 1, 2, 3 away on the other side, I've got another point that's a mirror image over there. Now I got a really good view of what my parabola should look like. If I wanted more points on my parabola, I could plug in 2 into my formula here. So if I wanted that point, I would do y equals 2 minus 1 and 2 minus 5. This would give me 1 and negative 3. 1 times negative 3 is negative 3. So that gives me the point. I plugged in 2, and I got negative 3 for y. So 2, negative 3, 1, 2, 3, is right here. And then on the other side of the axis of symmetry, I should get a matching point because it's a mirror image. And now I've got my parabola. There we go. All right, let's try it one more time. Something else. Okay, on this one, we're going to factor and graph. Remember when we factor, we always look for a GCF first. So let's factor out a 2 on this one. I'd be left with x squared minus 2x minus 3. Okay, so I'm looking for things that multiply to give me negative 3, but combine or add to give me negative 2. So this would probably be 1 and negative 3, because 1 times negative 3 is negative 3, and 1 minus 3 is negative 2. So this one would become, we have to keep this factor out here. This trinomial here would factor into x plus 1 and x minus 3. Okay, so the first thing we're going to do is find our x-intercepts, because factored form tells us what our x-intercepts are. Now remember, we're going to take the opposite of these two numbers to find our x-intercepts. We take the opposite because to find the solutions or the roots or the x-intercepts or the, what was the other thing that we were calling them? Solutions, roots, x-intercepts, zeros, that's it. Zeros of the function, we always make this equal to 0. So I'm going to take these two and set them equal to 0. So I do x plus 1 equals 0 and x minus 3 equals 0. Subtract 1 from both sides and x is equal to -1. Add 3 to both sides and x is equal to 3. So my two x-intercepts are at -1 and 3. Okay, so -1's right here and 1, 2, 3 is right there. Next step, find the axis of symmetry. So the axis of symmetry has to be right in between these two. That would be here at 1. 1 is halfway in between, nope, 1.5 is halfway in between those two. All right? So I got 1.5 is going to be right in between. No. This is 1, 2 away. This is 1, 2. Wow, my brain is not working this morning. It's 1. I was right the first time. Oh, it's a day. Okay, just stick with me. I'll figure out it sometime. You're probably staring at this going, what's he thinking? Yeah, I'm not thinking today. So that's the middle, right? Because it's 1, 2 away over here and 1, 2 away over there. How was I messing that up? I don't know. So x equals 1 is our axis of symmetry. It's 2 away from both of these x-intercepts. Now all we have to do is find the vertex. And we know the vertex is when x is equal to 1 because it's somewhere on this line here. So I'm going to take our equation that we made up here. So that's y equals 2. And instead of these x's, I'm going to plug in 1. So this would be 1 plus 1, and this would be 1 minus 3. So this is 2, this is 2, and this is -2. So 2 times 2 is 4, times -2 is -8. So this tells me that my vertex is, we plugged in 1, we got -8. That's my vertex. Okay, you find your vertex by plugging in your x value for your axis of symmetry. So where's that going to be? 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right here. All right. That's my y-intercept. Because the y-intercept is when I plug in 0 for x. So if I plug in 0 here, and I plug in 0 here, I'm left with -6. I could also plug in 0 here and here. I'd get 1, -3. So 2 times 1 times -3 is still -6. It's the same number right here. So my y-intercept is at 0, -6. 1, 2, 3, 4, 5, 6. And then on the other side of the axis of symmetry, we should get another point at 2, -6. And now I've got 5 points. My parabola is done. Close enough. Kind of bothers me right there. All right. So in order to graph using intercept form, you're going to factor it first, find the x-intercepts. The axis of symmetry is going to be directly between them, and then you're going to find the vertex using the axis of symmetry, because the vertex is always when the x value is the axis of symmetry. So I plugged in 1 for the x values because my axis symmetry was 1, and that gave me the vertex. And then we can use extra things like the y-intercept to find more points. There we go, and we are done. All right, see you guys later. Math hard. Bye-bye.